And from this moment on, we are recording. And then now let's go ahead and share that PowerPoint and make sure everybody can see the PowerPoint okay. Okay. I think sometimes, Teams is a great format, but it takes a little while to load things sometimes, I think. Okay. Okay, Tony, I'll let you kind of be my monitor today, if that would be okay. So everyone should see a low voltage review, TME, TMY, and TMV furnaces.
Yep, looks good, Joe.
That'll look good. Yep. Another thing I'd ask everybody just real quick, Tony and guys and team, do you see the little lights flashing on your audio or your video stream?
Yes.
Okay, well, that's good news then. So this is a little different way to approach Teams. We're actually streaming a desktop PowerPoint instead of uploading it into the cloud like we did before. So this looks like it might be a better technique. Well, team, I want to thank everybody for spending some time with us this afternoon. Let's go ahead and get started. I've got 2 minutes after the hour. And as promised, we try to kick off at the top of the hour on our training sessions. Again, I'd like to thank everyone for the opportunity to train with you today. And today we're going to be looking at the low voltage overview of our three main control boards that we sell the most of with our Winsupply locations. TME, which is a single stage high efficiency furnace, high efficiency indoor blower. TMY, which is a 2-stage with a high efficiency indoor blower. And then a TMV control board, which is going to be used on our 2-stage variable speed furnaces. So again, these are really great products, very, very versatile products. And today we're going to be covering some pretty important stuff. As a matter of fact, as we take a look at our PowerPoint presentation today, some key topics that we're going to be talking about will be the control board layouts. We're going to literally go over every input, every output on those boards. And again, if you have any questions, just unmute your mic and we'll take those questions as we go. We'd love to have your input on that. And then when you've asked your question, go ahead and mute your mic so that we can continue. Tony, real quick, this is just the next slide. Did the slide come up okay?
Yep,
with the
looks good.
Key topics, okay. We're also going to be talking about field selection of heating off delay timings. Now, team, one of the things about our furnaces, and this is universal across all of our champion furnaces, the factory on delay timing is set at the factory, but the off delay timing, in other words, how long the fan continues to operate after the call for heat goes away, that is field selectable, and we're going to show you where to find that on the boards. We're going to talk about the low voltage terminal wiring. This is very, very important. I believe if a technician can get his head wrapped around how to wire the thing, low voltage, especially the control voltage, he'll be a much better technician. And if he does have issues, he'll be able to identify those problems much quicker if he understands the low voltage wiring. We're going to talk about airflow adjustments and how to set the furnaces up for different airflow scenarios. We're going to talk about single stage thermostat use on a 2-stage furnace, because we know from a practical field standpoint, a lot of times what happens, you may not have enough thermostat wires behind the wall. You may have bid the job without thinking about replacing that thermostat wire. Maybe you just can't get to it. And so sometimes you're stuck with a single stage thermostat. Now, I would like to say right on the front end, we always recommend, your champion team always recommends, that if you put in a 2-stage furnace, put in a 2-stage thermostat. But we also realize that there are some things that occur sometimes in the field that you just can't do it. And so sometimes you're going to be stuck with a single stage thermostat. So we're going to show you how to get some staging on these 2-stage furnaces, some really cool ways to get some staging on those furnaces that's actually built into the control board. And I'd like to say that's one of the things I really like about our champion furnaces, is because we can actually let the control boards make some intelligent decisions. And we'll cover all that in that area when we start talking about single stage thermostat use. And then we're going to overview our communicating terminals on our variable speed furnace. That's one of the cool features about our variable speed furnace. It's a great product. It has a high efficiency variable speed motor, but it also has the capability to be communicating. And so with our communicating outdoor products, we're able to utilize this variable speed furnace in that scenario. So we're going to be touching on all that today. And again, Tame, if you have questions, please unmute that mic, and let's have those good questions, and then go ahead and mute that mic right back so we don't have any feedback or echo. So at this time, is there any questions or comments before we continue?
Good to go.
Okay, well, here we go then. Well, Tame, the first thing we're going to talk about is the single stage board layout for our single stage TME product. Now, remember, Tame, the TM8E would be an 80% product, and the TM9E is going to be a 95+% efficiency product. But the control boards on these things are going to be the same type of control board, and I would like to point out this is a single stage heating board. A single stage heating board, a TME product. And one of the things I think sometimes we forget about in the field, that even though this is a single stage heating board, it has two-stage cool capability. Now, one of the things I really like about this furnace is it's extremely versatile. You can literally hook this furnace up to anything in our inventory except the 20 and 21 SEER momentum product. And I didn't stutter. Yes, you could take this and hook this up to a 19 SEER 2-stage and get it to operate absolutely perfectly with two-stage cooling and single-stage heating. And so this is an extremely versatile product, and I think oftentimes overlooked, you know, when you're matching equipment up. If you want to hook it up to a single-stage 17 SEER, or if you wanted to hook it up to you could even hook it up to a dual fuel, a TH16 heat pump, and get a lot of capability with it. So it's an extremely versatile product, and I really like this furnace a lot. So without further ado, if everyone will please reference the left-hand side of the PowerPoint screen. Well, let's go over the low voltage terminals to start with and review those real quick, just to make sure everybody's singing off the same page. So looking over here on the left-hand side, Y1, that's your first stage cooling call, and that's pretty standard in the industry. I think that's pretty universal in the industry. So Y1 would be your first stage cooling call if you have a two-stage product outside. Y2 would be your second stage cooling call from the thermostat. Now you're also going to notice, Tame, that when we talk about two-stage terminals like this, it's very common for our champion engineers to have silk screened or labeled on the control boards Y/Y2. Now the reason they do that is this. Y1 is first stage cooling airspeed, which is going to be 65% of your total cooling airflow. You're going to have to set that up for 65%. Y/Y2 is your second stage airflow. But now hang on a second. The reason we say Y/Y2 is to remind you that if you have it on a single stage product outside, you have to have 100% airflow inside. Let me say that again. If you have a single stage unit outside on a cooling call, Y, you just have a Y going outside, you want to make sure and use this Y/Y2 terminal. And the reason I'm stressing that is sometimes we've had some field calls and we've had some technical calls where the contractor said, well, you know, my airflow is not what it should be, and I've got a single stage unit outside, so they use the Y1 input. No, that's not correct. The Y1 input is strictly for a two-stage product, first stage airflow, and then the Y/Y2 is second stage airflow on a two-stage product, or that's the terminal you use if you have a single stage product outside, because if you think about it, you want 100% airflow on a single stage product outside. Is there any questions or comments on that? Okay, good. Just wanted to make sure and stress that with everybody. Now, because this is a single stage heating board, we're only going to have one W terminal for heating. And sure enough, that's what we see. W is our heating call. R is 24 volt hot. And again, this is pretty standard in the industry. I think you'd expect to see that in the industry. R is 24 volt hot. G is our fan call from the thermostat, asking for fan operation. And C is 24 volt common. Any questions or comments on the low voltage terminal strip before we continue our tour, if you will, around the control board? Okay, as we continue on the left-hand side of the board, you'll see there's a set of jumpers on the upper left-hand part of the control board as we're facing the board right now. And you'll see it says fan speed. Now, team, this is your continuous on fan speed selection. Now, this is a really neat feature of our Champion furnaces. You know, a lot of our competitors don't have this. Basically, if you go to the thermostat sub-base assembly on some of our competitors' products, and you go to on the fan, the homeowner just wants to circulate air and run it across their clean air machine and their filters, keep the air moving and keeping it continuous filtration, which is a great idea, especially now, with all this virus and stuff going on. If you have clean air products, you probably want to keep that air moving across that filter. Well, a lot of our competitors, if you go and you just put the fan to the on position, you get full airflow, full cooling airflow, or maybe they have a little relay or something in there to give you half speed airflow. Well, we like to give you some selections. As a matter of fact, if you take a look at it, you'll see that your continuous on fan speed selection is G, which is just fan on, high cool. You could select high cool for your continuous on speed. You could select your heating speed. You could select your low cool. So it's just one of those little things I like about our furnace. If you have a continuous fan operation, demand or desire, you can actually select how fast the fan's going to run: high cool, low cool, heating speed, or just G fan or G low fan speed if you want to do it that way. So it's just kind of a neat little feature. Now, right above the fan speed is our heating off delay. Now, this is our heating off delay. It's field selectable, as I said earlier. From the factory. It's going to take 30 seconds. So from the time the furnace sees flame proving, 30 seconds later, the fan comes on a heating call, the indoor fan. Now that's set from the factory. You cannot change it. However, how long does the fan run after the heating call goes away? That's what this jumper is about right here. This is a heating off delay jumper, and it goes all the way from 60 to 180 seconds. Now, we typically set it up at 90 to 120 seconds, about in between from the factory. But you've got that field selectable capability of changing from 60 to 180 second off delay when the call for heat goes away. So that's pretty nice from a comfort standpoint. If the homeowner's complaining that they love our furnace, but it kind of blows cold air after a couple minutes, well, you can take that down to 60 seconds or 90 seconds if you want to help improve that comfort complaint. If you're getting like a cold blow complaint at the conclusion of your heating cycle. Any questions or comments on how I'd use those jumpers, or any questions on the low voltage terminal strip?
Yep, makes sense, Joe.
Okay, well, sounds good. All right, team, right above that, we have a last error button. That last error button, it allows you to go in and pick up the last error codes on the board. The board will remember the last 5 error codes. And you'll notice there's an LED flashing, and what that is, you can actually pick up error codes off that LED. Now, it should be noted that last error button, if you hold that button down about 10 or 15 seconds, it'll clear that error memory. And so, again, you can cycle through and pick up the last 5 error codes. It remembers the last 5. Another way of thinking about it is the most recent 5. It remembers the most recent 5 error codes. And you can reset it by holding that button down. Right next to the last error button, as we move around towards the top of the board, you see there's a status LED. This status LED will flash error codes for you. And as you take a look at the install information that comes with the equipment, you'll have a deep explanation of what those error codes are. Now, it should be noted that LED will flash one of 3 colors. It's just one LED, but it's a tricolor LED. It'll flash green, amber, or yellow. I like to call it yellow, but I think in the book they call it amber, and red. And so this tricolor LED, it's real simple to look at. Basically, if it's flashing a red 3 code, you'll look that up, or if it's flashing a 2 green or whatever the case may be. But just remember, team, that LED is a tricolor red, yellow, or green LED, and then you look in the install information to refine exactly what it's telling you. As we move around towards the top of the board, you'll notice there's some 24-volt motor terminals. You'll see that there's one that says Park, and then G, where you can actually select a motor speed for a G only call, as per our fan speed jumper that we talked about a little bit ago, and then 24 volt common. Now, team, at this time, I want to kind of remind everybody something about all ECM type motors. Now, that ECM, or that high efficiency motor, in a nutshell, it's a high efficiency motor that has power to it all the time. Now, this is important that you wrap your noodle around this. These motors have high voltage to them all the time, but they're just sitting there doing nothing until they get a 24 volt command. So that's the first thing about an ECM motor I wanted to remind everybody, a high efficiency motor. They have power to them all the time, and then you command it to do something with 24 volt inputs, whether it's from a control board or a physical jumper that you make on the motor. It's all the same principle. High voltage to it all the time, and then you tell it what to do with 24 volt commands. The other thing about all ECM high efficiency motors, whether it's a standard ECM motor like what we're talking about here, or if it's a variable speed motor, they all have the same function I'm about to touch on. And that's this. Not only do they just sit there with power all the time, like we talked about, waiting for a 24 volt command, in addition, if they have more than one 24 volt command, in other words, you could have several commands going to that board, or to that motor. You could have a low cool, you could have a high cool, you could have, if it's on a heat pump, you could have an auxiliary heat command, and so on. So that motor may be receiving more than one 24 volt speed command. Now put your thinking cap on for a second. On a regular PSC or permanent split capacitor type of motor, if you commanded more than one speed command on that motor at the same time, you'd burn the thing up, right? So one of the things that I really, really like about high efficiency ECM type motors is the fact that you can give it multiple speed commands and it will always go to the highest speed command that it's getting. So let me say that again. It's a 24 volt driven command. And if it has more than one 24 volt speed command on it, whether it's by way of a control board or a physical jumper like we have on this particular type of furnace or control board, if it has more than one speed command, it will always go to the highest speed command that it's getting. We call that airflow priority. So that's, those are just some of the highlights about the ECM type of motor that I really, really like. I'm really glad that we've got some of these high efficiency motors, because they're very powerful motors. They deliver airflow really, really well. They actually have some ramping function, even on the plain TME type of control boards. They actually have some ramping function on the motors. They're just a good heavy duty motor, and I like them. As a matter of fact, it's what I've got in my own house, in my own garage. I have an ECM type of air handler in my garage, and it's just been wonderful in my shop. So I really like this motor technology. Any questions or comments on that quick overview before we talk about speed selections and some of our other inputs on the control board? Okay, well, let's continue around our control board then. We see that we have some blower speed tap selections: low cool, high cool, and heating speeds. And again, these are all speed wires or speed taps that will go down to the motor that you're going to have to select. Now, from the factory, we always set them up towards the higher numbers, but based on your ductwork, make sure that you select the speed according to give you the proper airflow. And as a quick reminder, team, we always design our ductwork and we always set up our speed taps on cooling for 400 CFM per ton of cooling, 400 CFM per ton of cooling. And then on the heating speed, we want to make sure and look at the data plate on the furnace. If you'll take the service panels off the front of the furnace and turn them around, you're going to notice there's a data plate in there. And on that data plate, you're going to have a temperature rise range on the heating speed. So in other words, let's say, for instance, my temperature rise is 30 to 70 degrees. I want to select a heating speed tap on my motor to put me in a temperature range of about 50 degrees. So right about in the middle is where I normally try to put it for comfort. And again, the way you find temperature rise, team, as a quick review, is you take your supply air temperature in the heating mode, you take your supply air temperature and your return air temperature, and you find the difference between those temperatures, and that's the temperature rise. And then the temperature rise range will be found on that data plate on the service panel. So when you're tweaking and you're making final adjustments and selections on your heating speed on the furnace, don't forget, do your temperature rise, look at the data plate, and then adjust your heating speed to get you right about in the middle of that temperature rise range for comfort. But it also gives you a little bit of flexibility as that indoor air filter gets dirty. Any questions or comments on blower speed tap selections and some of the considerations I should have when I set them up?
Good to go, Joe.
Okay, sounds good. And Tony, the PowerPoints and everything seem to be working okay as far as the text fields and the light blinking and all that?
Yep, very smooth.
Very good, thank you. Okay, team, right below that, below our motor speed taps, we have 120 volt output. It's an EAC, that's for an electronic air cleaner. And please make a note of this, that EAC will be energized anytime the fan is running. We'll have 120 volt output to run an electronic air cleaner. Right below that, we have a L1, and what that is, that's an input. That's actually an input to the into the board for 120 volt components. So we have an input to the board, 120 volt input to the board. The XFMR, what that is, that's the 120 volt primary lead going to the transformer. So XFMR is 120 volt primary lead going to the transformer. Now right below that it says line. Now it should be noted that line is actually power to the motor. Now remember, we said that on an ECM type of motor, we have power to it all the time. Well, that's where we power the motor up all the time, is where it says line. That goes over to the ECM motor. That's the hot power, if you will, or 120 volt line voltage to the ECM motor all the time. Now remember, team, that motor's not running. It's waiting for a 24 volt command to tell it what to do, but we have power to it all the time. And now the reason I'm stressing this is the fact that from a safety standpoint, you know, don't presume that that motor's not energized just because it's not running on these types of furnaces. And so from a safety standpoint, we always recommend you shut the power off and let it sit at least 10 minutes before you take the module, or before you take that module off in the back of the motor, because they've got some really big capacitors in there inside that motor control on the back of that high efficiency motor that'll hold voltage for high voltage now, you know, for several minutes. So please, before you handle that motor, before you change the module or pull that module off the back or troubleshoot that module, please shut that power off and let it set at least 10 minutes before you get your paws in there, because those capacitors will hold a charge. Right below that, we have a HUM terminal, and what that is, that's 120 volt output from the board to power a humidifier if you want to utilize that terminal to power a humidifier. Below those high voltage terminals, we've got 4 neutral terminals. And by the way, all those neutral terminals are just, they're bussed together. If you were to take that board and turn it around backwards, you'll see they're all tied together. And those are your neutral terminals. That's where your white wires for your 120 volt components are going. Is everybody good so far? Is there any questions or comments on our layout of the board so far? Okay. Well, let's continue then, team. Below our neutral terminals, we see we have an output harness to the hot surface igniter and the inducer fan. Now, at this time, I'd like to go ahead and stress something to everyone. All the harnesses from the factory are hooked up to this board. In other words, these harnesses, these output harnesses to the hot surface igniter and the inducer fan, that's all hooked up to the factory. So when we're doing our training today, team, just please bear in mind, we've removed all the harnesses just so we could talk about the board and the components on the board, and it makes it easier to look at the board if the harnesses and stuff are off. But you know, as an installer or whatever, you don't have to hook all this up. I just wanted to remind everybody that we've taken the terminals off the board and stuff just so that we could talk about them in class. So that's where your output harness goes to your hot surface igniter and your inducer fan motor. Now this is a feature that I really like about our Champion furnaces as well. All of our Champion furnaces feature a flame current pad, Now what this is, it allows you to take a regular voltmeter. Just take your regular voltmeter and put it on DC volts, and then go between those two little silver, or those two little solder terminals there with your leads on your voltmeter, and you can read flame current with the furnace running, you can read flame current with your voltmeter now. So now you don't have to have a special flame current meter like we used to have in the old days, where we had to have a special meter to read flame current, and then you'd have to pull the the flame sensor wire off and hook your meter in series and all that stuff. We don't have to do that anymore. So with all of our Champion furnaces, we have a flame current pad, and what that does, it allows you to take just a plain Jane voltmeter, which you're going to have on your truck anyway, and go to DC volts and read DC volts between those two terminals. Now remember, team, 1 volt DC is equal to 1 microamp flame current. And so again, 1 volt DC is equal to 1 microamp flame current on that flame current pad. Now please write this down or make a little note. When you're troubleshooting our furnaces, typical flame current should run between about 3.5 to 4. So about 3.5 to 4 would be normal. If it falls below 1.5, you're going to get an amber flash code. And then if it falls down to 0.1, that's 1/10 of a microamp. If it falls down to 0.1 microamp, it'll go ahead and lock the furnace out. So just kind of write that down or keep that in your mind, that flame current and reading flame current on your service calls is very, very important. 3.5 to 4 is considered a normal range. 1.5, we start generating an amber flash code to let you know there's a problem. And then at 0.1, we actually lock it out. Now, before we get off of flame current, this is kind of one of my pet peeves with furnaces. Please write this down or make a mental note of this. The #1 cause of poor flame sensing or low flame current is grounding. You got to have a good solid ground on these furnaces in order for it to see the flame or to sense the flame properly. So if you have an older home, make sure and double check that you've got a good solid ground all the way from the furnace to the power panel, and then bonded down to earth ground, because if you don't have a good ground, you won't have good flame sensing, and then of course you're going to have erratic operation with the furnace. Any questions or comments so far on what we've covered? Okay, sounds good. Well, let's go ahead and continue then, team, with our training overview. We have a 3 amp fuse. It's a 24 volt fuse. And that's a 3 amp fuse, 24 volt for all onboard components on the board. So this fuse basically is your main fuse for the board for all 24 volt components for onboard protection. Right next to him, we have a 12-pin harness. This 12-pin harness this is where we have our 24 volt inputs and outputs. The things that would be plugged into that 12-pin harness would be things like your gas valve, your pressure switches, your flame sensor, and all that's going to be plugged on in there. So is there any questions or comments on the single stage board layout for the TM8/9E control boards? Okay, team, let's go ahead and continue then. We've got a couple more boards to talk about. And again, if you do have any questions, please unmute that mic, ask those good questions, and we'll go ahead and address those questions for you as well. And we are going to pick the pace up a little bit. We're going to try to get this entire session in today in under 90 minutes. But that doesn't mean don't ask good questions, because if we touch on something, we're going to be touching on some things that are pretty redundant as we go through the boards, especially the low voltage wiring. But that doesn't mean don't ask good questions. Please, if you have a question, let's get those questions as we move forward. So on a 2-stage board, this is a 2-stage gas heating and also 2-stage cooling capable board. And you're going to find this on a TMY series of furnace. Now the TM8Y, of course, is 80%, and the TM9Y, I think, gets up to about 96 or 97%. This is a great furnace. Again, very, very versatile. It will literally match up with anything in our inventory except the 21 SEER momentum and the 21 and 20 SEER momentum fully communicating only product. So as we start on the left-hand side, team, like we did before, Y1 is your first stage cooling call. If you have a 2-stage product outside, Y2 is going to be your second stage cooling call. Because It's two-stage. W/W1 is going to be your first stage heating call. Now, by the way, if you have a single-stage thermostat, if you're stuck with a single-stage thermostat, be sure and hook your W call from your thermostat to that W/W1. That's what our engineers are doing when they give you that double terminal there. That W/W1 means if you're stuck with a single-stage thermostat, you just hook it to W/W1. If you have a two-stage thermostat, you hook your W1 to the W/W1. Any questions on that? Okay, W2 is your second stage heating call if you've got a two-stage thermostat. R is 24-volt hot, just like we had before. E is our fan call, just like we had before. And finally, C is our 24-volt common on our low voltage terminal strip. Is there any questions on the low voltage terminal? Okay, team, as we move around the board, just like we had before, towards the top of the board, we have a last error button. We can retrieve errors, and again, just like before, the last 5 errors are remembered. If you hold that button down about 10 to 15 seconds, you'll reset the memory. We have a tricolor LED, just like we had before. It'll flash either red, green, or yellow based on the flash code that you're looking at. Now on this board, we feature some dip switches. On our other boards, you notice we had some physical jumpers. Well, on this board, we have some dip switches. So our continuous fan on speed selection is going to be found with a couple of dip switches. So basically, as you take a look at your photo there, you can see that you've got 2 dip switches that you're going to move up or down, and to give you a combination of low heat, low cool, or high cool, continuous fan operation. So remember, team, again, this is if the homeowner goes to the thermostat sub-base assembly and they switch the fan from auto to on because they want to have continuous fan. How fast does the fan run? Well, that's with those dip switches right there. You can field select your continuous fan speed if there's a G only call on the board, a G only call from the thermostat on the board. Right next to that, you have your heating blower off delay. And again, these are dip switches. And you'll see that based on, if you look at the little diagram there, based on the position of those switches, we have 60, 90, 120, or 180 second heating off delay. Now remember, team, all of our boards are set up for a factory on delay of 30 seconds. So once we get flame proving on a heating call, 30 seconds later, the indoor fan comes on. That's factory set, you can't change it. However, the heating off delay you can change with those switches. Now, team, remember I told you that we were going to talk a little bit about staging with a single stage thermostat. Now, we always recommend, your champion team here always recommends that you use a 2-stage thermostat on a 2-stage product. But sometimes we know that you might be stuck with a single stage heating thermostat. Maybe you don't have enough wires. Maybe grandma just loves that old Honeywell round, whatever. The point is that you can still get some staging on this furnace with some intelligence built in on the board. And that's what these 2 dip switches are for. They're called staging dip switches. Now you'll notice that there's some positions on those dip switches. If both of those switches are off, if both of them are in the up position, that's the off position. You'll notice there's another position where it's if one dip switch is down, the other one is up, that's 10 minutes. You also have an auto function. Again, you know, if the left one is down and the right dip switch is up, that gives you auto. And then if both dip switches are down, that gives you 20 minutes. So what this is if I get a W/W1 call from the thermostat. Now remember, team, I'm stuck with a single stage thermostat. So I get a W call, W/W1 call on the control board. If those dip switches are in the 10 position, what'll happen if the furnace runs for 10 minutes on first stage, it automatically goes to second stage to finish the heating call. Likewise, if it's on 20, if the furnace is running 20 minutes on a heating call, remember we're stuck with a single stage thermostat. If it's running 20 minutes, it'll kick into second stage to finish the heating call to thermostat to satisfy the thermostat. Now watch this, I saved the best for last. If those dip switches are in the auto position, what that does is it plugs in some intelligence on the board. And inside that board, inside the programming of that board, if those dip switches are in the auto position, what'll happen if it gets a W call, it starts counting and starts monitoring the time that the thermostat takes to satisfy. And then it starts making intelligent decisions on when to stage second stage. So to give an example, let's say, for instance, we had 3 cycles and it took 17 minutes to satisfy the thermostat. I'm just making that number up. Well, on the 4th cycle, it might run 8 minutes on first stage and then 4 minutes, or to see how long it took on second stage to satisfy the thermostat, and so on. So this board starts learning thermostat activity and optimal staging sequence by looking at the thermostat activity with a single stage thermostat. So it's really, really important. Now, you do what you want to do, but I think what I would do if I was in the field and I was stuck with a single stage thermostat, I'd make sure that that was in the auto position and let the board make some intelligent decisions on when to stage. Please write this down or make a note of this. Don't put those dip switches in the off position if you have a single stage thermostat, because you'll never get out of first stage. You'll never have more than first stage heating. And so please make a note of that, or mental note of that. If you're not going to use that staging function, if you're stuck with a single stage thermostat, put it someplace other than off. Even if it's 10 minutes or 20 minutes, auto is recommended, but the only time those switches should be in the off position is if you have a 2-stage thermostat to where you can actually control W/W1 first stage heat and then W2 second stage heat. Any questions or comments on those staging dip switches and the cool feature that I've just described to you?
None here.
Okay, sounds good then. Well, let's go ahead and continue, team, as we work around our boards and talk about all the features on these boards. There's our blower speed tap selections. You see we have a park terminal and a common, as well as a high heat, low heat, high cool, low cool, because again, 2-stage heat, 2-stage cool board. Right below that, we have a 120 volt EAC terminal for an electronic air cleaner. Now remember, team, that it is 120 volts, so be careful. Below that, we have a circ terminal. That circ terminal is that wire that powers up the ECM indoor blower all the time. Remember, team, the ECM blower is powered all the time. That's where we grab power. We call it circ on this board. The last board, we called it line. On this board, we call it circ. And so that's our high voltage going to the motor all the time to power it up. L1 is our 120 volt input to the board like we had before. XFMR is our transformer terminal just like we had before. And on this board, we also have a humidifier output of 120 volt called the Hume terminal. Below those 120 volt outputs, we have a neutral bus. Looks like we have about 5 or 6. We have 5 terminals on that neutral bus. This is where your white wires are going to come in, and it's just a common neutral bus. Now, because this is 2-stage heat, you'll notice that we have a harness down below, that output harness to the hot surface igniter and the inducer fan, and we have additional terminals on there because it's a 2-stage product. So if you've noticed that from the last board we looked at, the last board only had 4 terminals on here. This one has 5. It's because we have a 2-stage inducer on its 2-stage heating product. There's our 12-pin harness with our 24 volt inputs and outputs to our gas valve, our pressure switches, and our safety circuits. In the lower left-hand corner of the board, you'll notice there's a 3-amp fuse for 24 volt on-board protection. You'll also please note that we ship it with a 3-amp fuse. But if you look at the silk screen on the board itself, 5 amp is a maximum is a maximum permitted fuse on that. So we do give you an onboard protection of 3 amp, but you can go up to 5 amp if necessary with that fuse. Now on this board, team, please notice about in the middle of the board, off to the right-hand side, there's your flame current pad. All of our Champion furnaces feature the flame current pad. And again, you'll just take your voltmeter leads and your voltmeter set on DC volts, and 1 volt DC equals 1 microamp flame current. Team, that's it for this board. We've got one more board to look at to wrap out the training. So we're 2/3. We've gone 2/3 towards home run, so to speak. Is there any questions on the TME, the TMY, TM8/9Y control board layout before we talk about our variable speed control board as we start rounding out this afternoon of training? Any questions or comments on the TM8/9Y two-stage heat, two-stage cool control board? Is everybody good? Okay, Tony, everything's still looking good, and audio's good and video's
Looks
good?
good. Yeah, looks good, Joel. What are some questions? I know that you have typically conducted this class with live groups. What are some of the questions that you often hear from installers and technicians as you go through the mechanics of the boards and so forth?
You know, that's a good question, Tony. We find that, our contractors out there, they're pretty darn sharp, and they've got, they've got the low voltage wiring down. They've got selecting speed taps and stuff down. But the things that kind of excites them a little bit is the fact that, in the field, a lot of times they'll be stuck with a single stage thermostat. And a lot of our competitors' products, they really don't have any way to deal with that as far as staging. Now, some of them, some of our competitors, they'll just have a timeout function. If they see a W1 and W2 call, they'll just have a factory set timeout of, say, maybe 5 or 10 minutes. So the one thing they like about our board, it seems like a lot, is, I spend a fair amount of time talking about the staging, the staging of the board if you're stuck with a single stage thermostat. They seem to really like that a lot. But as far as the other stuff, it's pretty straightforward. The other thing they really like is the fact that we build in a flame current pad, so they don't have to have a special meter now to read flame current on their service calls. Good question. Good question. Any other good questions or comments? Okay, team. Well, I'll tell you what, then let's go ahead and start rounding out this training session this afternoon. With our two-stage variable speed board. Now, again, we advertised and have blocked out 90 minutes for this training, and it looks like we're coming up to about 54 minutes. But that doesn't mean don't ask good questions. One of the things that Tony and I and all of your champion team want to always stress that when we're doing these training sessions, we're here for you. And even if we have a little time thing on there, we're going to make sure and answer those good questions. And we don't want you getting off this meeting with questions on the training subject at hand. So as we take a look at our two-stage variable speed board, this will be the control board we're going to find on the TMV product, the TM8V and the TM9V product, meaning variable speed. Now this is a high efficiency motor as well, but it's a full variable speed board. The big difference between this and the previous boards that we talked about, instead of setting up airflow by you selecting a speed tap and a physical wire that you're going to change on the motor itself, this board's going to give you some jumpers to select airflow. So that's the big thing with the variable speed. You're going to have a control board and some jumper selection for your airflow selections instead of you physically going down and moving a wire on the control board or moving a physical wire on the motor itself to select speed taps. In addition, on the variable speed board, you're going to notice we're going to change our vernacular, or more specifically, our terminology a little bit. And as we talk about cooling airflow and heating airflow, on a variable speed product, we start using the terms percentage of airflow. So as we talked about high and low airflow before, Y1 and Y2, on this board, you're going to notice I'm going to start referencing percentage of airflow when we have a Y1 and percentage of airflow if we have a Y2 second stage cooling call. So be prepared for that. But other than that, this is pretty straightforward. This board is communicating capable. We'll talk about that in a minute or two. But let's take a look at those low voltage terminals on the left-hand side, because they are a little bit different than the previous boards that we talked about. So starting out is 24 volt common on the low voltage terminal strip to the left. C is 24 volt common. That's very straightforward. G is our fan call. R is 24 volt hot, just like before. On this board here, because it's a two-stage heat, two-stage cool board, your W/W1 is your first stage heating call. And just like before, remember, team, if you're stuck with a single stage thermostat, don't forget to put your to land your heating, your W terminal, on that W/W1 if you have a single stage thermostat. But if you have a two-stage thermostat, your first stage heating, W1, lands on that terminal. Y/Y2 is your second stage cooling call. Now please write this down or make a mental note of this. If this board sees a Y/Y2 input on this terminal, it drives the fan to 100% cooling airflow. Let me say that again. Y/Y2, if I get a 24-volt signal on Y/Y2, it drives the fan to 100% cooling airflow. However, if it sees a Y1 call all by itself, with a cooling call now, it's going to drive the fan to 65% of whatever cooling airflow you've got set up on the board. So a Y1 call is 65% of your total cooling airflow that you've got set up on the board. A Y/Y2 call is 100% airflow. Now watch this. If I've got a two-stage product outside, my thermostat's going to generate a Y1 and a Y2 and a G call on a cooling call, right? And if it's a heat pump, it's also going to have an O terminal energized as well. So now this control board could actually have 3 fan speed inputs to it. G, Y1, Y2. Well, shucks, I wonder what speed it's going to run at. Remember, team, on any high-efficiency ECM motor, including the variable speed, because it's also a high-efficiency ECM motor, if I have more than one speed command, it always takes the highest speed command priority. So if I have a Y1 and a Y2 and a G call, it's going to drive it to Y2. If I've got a Y1 and a G, it's going to drive it to 65% airflow. If I've got a G-only call continuous fan, it's going to look at a jumper that we're going to talk about in a little bit, and it'll drive it to that speed. So this is an important concept with ECM type of motors that, you know, they're sitting there, they got power to them all the time, and then we drive it or command it with 24-volt commands. It's no different on this. It's just that the board's doing more on a variable speed, because now on the board, we're going to actually have some jumper selections where we can set airflow on the board instead of physically having to move a wire down onto the on the motor itself. Is there any questions or comments on that so far? Everybody good with that? Okay, because we have a two-stage heating board, W2 is our second stage heating call. Now watch this. This is a very unique feature on our variable speed products. This dehum is actually a cooling dehumidification call. And so what happens is if I have my dehum, or if I have my hum jumper, which we'll talk about in a little bit, in the yes position, if I've got a hum jumper in the yes position, or humidistat jumper in the yes position, it's going to be looking at that terminal. Now watch this. Write this down or make a note. If my humidistat jumper is in the yes position, it's looking for an input on that dehum terminal in the cooling mode of operation. If it doesn't see 24 volts on that input in the cooling mode, it will not allow the fan to run any higher than 85% airflow. It's a dehumidification function. Now watch this. If the humidistat jumper that we're going to talk about in a little bit is in the no position, it ignores that terminal. So if you don't want to use that dehum function with a humidistat hooked up to that in the cooling mode, make sure that humidistat jumper is in the no position. Because if it's in the yes position and you don't have anything hooked up to that terminal, guess what? You'll never get above 85% cooling airflow on a cooling call. Any questions on that? Okay. Below that is an O for a cooling mode on a heat pump. This board is set up to be hooked up to a heat pump dual fuel. Just make sure that if you do have it on a heat pump, you have to configure the board and let it know it's on a heat pump by a jumper. And we'll show you where that jumper is in a little bit, where it says heat pump or AC. So make sure if it is on a heat pump that you have the jumper set to heat pump HP or heat pump yes, no, and then it'll be looking for that O terminal for the reversing valve on a heat pump in the cooling mode. top of the board, we see we've got our fuse spade terminals. I don't know why I don't have a fuse on this photo, but 5 amp maximum, and we typically ship these boards, all of our boards, with a 3 amp fuse, but 5 amp maximum on this board. As we move around the top of the board, team, you're going to notice there's some communication screw terminals. That's if you want to have this furnace set up with a 4-wire communicating system. So again, from our hex thermostat on the wall, you'd have 4 wires coming down to A, B, C, and D. I mean, it's going to be A, B, C, and R, and for communicating capable. So this is a communicating capable board, or you can hook it up 24 volt. One of the things I really like about this furnace is the versatility. Excuse me, one more time. It can be communicating, it can be 24 volt. It'll match up with anything in our inventory as far as our communicating capable products. So you could hook this up to a 13 SEER, no sweat. You could hook it up with a Honeywell zoning system, no sweat, 24 volts. You can hook it up with our communicating zoning system. Just a really, really great product. Right next to that is our tricolor LED. Again, it'll flash red, yellow, or green based on the flash code present. There's our last error button where you can retrieve errors. We talked about that. It's the same thing on this board as we had before. This board is kind of unique too because it's variable speed. It has a little CFM light. If you see that CFM light, remember, team, anytime the fan is running, it's going to flash 1 time for every 100 CFM the fan is running. So what it does, it actually looks at the RPM of the fan and the airflow setup jumpers that we're going to talk about in a little bit, and then it extrapolates by the torque and the RPM and the rotor position of that fan. It extrapolates what our CFM is. So one flash equals 100 CFM anytime the fan is running. Now, if you decide to go communicating with this control board or with this furnace, if you decide to go 4-wire communicating, you get some optional temperature, auxiliary, and float switch terminals as well. So you can hook up some accessory devices if you have them set up for communicating. You'll kind of a little key or a little visual cue as well. You'll notice the communicating terminals are little green screw terminals. Same way with that, little green screw terminals go with the communicating. So you kind of keep that in the back of your brain. If you're going to go communicating, you have available some accessory temperature, auxiliary, and float switch terminals if you go communicating. Right next to those terminals, you have an ECM motor plug. This is a 6-pin plug that goes down to the motor to command the motor what to do. Now, those are going to be 24 volt outputs. And so just like before, all ECM motors have power to them all the time. And we're going to tell it what to do with 24 volt commands. And that's what's going to command that motor by that 6-pin ECM motor plug from the board. As we come around the board, we've got some neutral terminals, some spade terminals, as well as a 6-pin neutral plug. And then again, that'll all be harnessed in from the factory. All the neutrals will come to that point. Now, because we have a multi-speed, or I should say a multi-stage furnace, we're going to have a 5-pin plug, and we're going to have a 2-stage we're going to have a 2-stage we're going to have a 2-stage inducer, high and low speed. We're going to have a hot surface igniter, and our transformer primary will all be tied into that harness right there. So you notice there's like 5 pins on that harness, and that's going to be for our hot surface igniter, our transformer primary, and then our inducer, high and low speed. As you move down the side of the board, team, you're going to notice there's a humidifier terminal. Again, that's 120 volt. To operate a humidifier anytime we have our heating call, if you want to power your humidifier right off the board. And let me say something about this too while I'm on this line of thinking. One of the things that's kind of cool about the Champion furnaces is, you don't have to have a lot of accessory boards and stuff to hook up some of the common things that you're going to see out there in the industry. For instance, like a humidifier, an electronic air cleaner. You don't have to have you don't have to run special power sources or anything like that. A lot of that's controlled right on our board. And I like that because now you've got some isolated relay outputs. As a matter of fact, those 2 little black relays right beside those terminals, those are isolated, typically 1 amp, 120 volt relays, and they give you some nice isolation on the electronic air cleaner as well as the humidifier. And so right below that Hume terminal is our EAC output. Again, on our furnaces, that's 120 volt output. It's an electronic air cleaner terminal, and that will be energized by way of that isolation relay, I might add. Anytime you have a G call or anytime the fan is running, you'll have an output on that EAC terminal. Any questions or comments on the low voltage terminals and the harnesses and the stuff that we've talked about before we get into some other key features with this, specifically our airflow jumpers and how to set all that up as we start winding towards a conclusion of our training this afternoon, probably in about the next 15 minutes or so. Any questions or comments?
Good here, Joe.
Okay, well, that sounds good. Thank you, Tony. Is everything still looking good and streaming good on the PowerPoints?
Yeah, looks good.
Fantastic. Thank you for that input. Team, along the bottom of the board, we have our flame current pad. We've described that pretty thoroughly in the last couple sessions or the last couple slides. With our other boards, it's the same thing. 1 volt DC equals 1 microamp DC flame current. And again, the real cool thing about that is now you don't have to have a special tool or a special meter to read flame current. And by the way, I recommend on every yearly clean and check, double check that flame current to make sure that that flame sensing circuitry is in good shape. And again, just plant this in your brain. If you have low flame current, the #1 cause is going to be poor grounding. And then the #2 cause right behind that is a dirty flame sensor. So kind of keep those kind of in the back of your brain. If you're having some flame sensing or low flame current conditions. There's our 12-pin harness, 24 volt inputs and outputs. Again, team, you're going to find that your gas valve and your pressure switches and your safety circuits and your FP, your flame proving circuits, will all be plugged into that 12-pin harness. Now, on the variable speed control board, we're going to have some jumpers that are going to be really important that we look at our install information with, and to set these jumpers up properly for our airflow. Now, remember, team, we never set it up for your ductwork. So when you install these pieces of equipment, it's really, really important that you look at the install information and set them up according to your ductwork and the tonnage of the outdoor unit. One more time. 400 CFM per ton is where we want our cooling airflow. 400 CFM per ton for our high cooling airflow on our products. So this delay jumper is pretty unique to our variable speed products. This delay jumper is going to allow you to adjust the fan based on your geography. Now, what I mean by that is this: if you have a humid environment or a dry environment like out in the desert or so on, or a temperate environment like we maybe would find in Kentucky or Tennessee or South Dakota, that type of thing. This delay jumper, what it does is it allows you to build in a delay for the indoor fan and the cooling mode. So to give an example, on the B selection, B, that's the humid selection like we have down here in Alabama, where I'm living down here in Alabama. We always set variable speed furnaces and variable speed air handlers on the B selection, because what that does is on a call for cool, it keeps the fan at 50% airflow for 1 minute. Then if the call for cool is still there, it ramps the fan up to 82% airflow for another 6.5 minutes. And then if the call for cool is still there, it ramps it on up to 100% airflow. Now, what that does for you is this: that delay jumper, by setting up these different airflow ramping profiles in the cooling mode, it allows you to pull more moisture out of the air every single time the unit runs. Because remember, team, just some of the basic physics of the refrigeration cycle, the air conditioning and refrigeration cycle, the colder the evaporator, the more moisture you're going to remove from the air going over it over a period of time. So we're going to utilize that function or utilize that science with this delay jumper. So in the humid profile, we start the fan out at 50% airflow, then we ramp it up and to about 82%, and then we ramp it on up. So we have this stepped airflow to help really pull extra moisture out in the cooling mode of operation. On the dry profile, and again, look at your install information to find out, to confirm which jumper selection that is. On the dry profile, like out in the desert in Arizona, New Mexico, places like that, southern Colorado, what we do is we just ramp the fan up over about a 15-second airflow, and now we're at 100% airflow. You don't need to pull extra moisture out. You're more interested in capacity and getting the air moving and cooling the space down, right? And so these different airflow profiles are really, really unique, to this variable speed product, and utilize that. Now, when in doubt, leave it on A, where it comes from. It's still going to work fine. You'll get some ramping, but if you really want to tweak that comfort, and you really want to tweak that indoor air quality, and you really want to tweak the comfort of your customer's home, this is one way to do it, by looking at that, understanding it, and studying that cooling airflow delay based on your geography. Any questions or comments on that? Tony, you remember in your other manufacturer's days, as well as I do, that's the old BK circuit. Remember that?
Yep, absolutely.
Okay, here you go. Team, the next two jumpers we're going to talk about are the cool and the adjust jumper. And if we were actually sitting in our class to where we had a workbook and everybody was in front, you'd be looking at page number 36. But that page number 36 in our workbook in class is actually just a copy of what comes with the install information. It was just a copy of the install information. So please look at the install information and see that the cool and the adjust jumper, they work together to set your cooling airflow. Now, this is really important. Let me say one more time. Cool and adjust work together to set your cooling airflow. Now, this is 100% airflow you're setting up. So the cool and the adjust have to be set up according to the tonnage of the outdoor unit. If you've got a 2-ton outdoor unit, you're going to set cool and adjust up for 800 CFM. If you have a 3-ton unit outside, you're going to have to set cool and adjust up for 1200 CFM, and so on, 400 CFM per ton. Now remember, team, you're going to set the cooling airflow, the maximum cooling airflow for the tonnage of the outdoor unit. But hang on a second. If you've got a 2-stage unit outside, you've already set this up for 100% airflow, cooling airflow, but the board is smart enough that if it sees a Y1 cooling call in a 2-stage product, it's smart enough to automatically reduce that cooling airflow to 65%. So again, just one of the nice things about the variable speed board, once you set your airflow and stuff up, the board makes some pretty intelligent decisions on the input that it gets from the thermostat. So it's a good board. It's easy to set up, but remember, your cool and adjust work together for your cooling airflow, and it's the 100% airflow you're actually setting up, and then the board will make a decision on cutting it back to 65% if you have a Y1 only call. Questions or comments on that so far? Is everybody good? Okay, right below your cool jumper is your heating jumper. Again, we referenced page number 36 in the workbook if we were actually having standing in front of you with a class, but it's all inside the install information, typically towards the back pages. That's your heating airflow. That's your heating airflow on your W2 call. There's that humidistat, yes or no. Am I going to use that dehume function? And if I use that dehume function, I'm going to set it to yes, and then I'm going to have that dehume. I'm going to have a humidistat on that dehume function over there. If I'm not going to use that dehume terminal on the left-hand side over there, team, remember that has to be in the no position. Because if I have it in the yes position and there's no input on that dehume terminal in the cooling mode of operation, what's going to happen, it'll reduce that airflow to 85%. Cooling airflow, and that's as high as you'll ever get. So please, if you're not going to use that function during your setup and your commissioning, make sure that humidistat is in the no position if you're not going to use that. Right below the humidistat jumper, you have a heat pump jumper. This is where you tell the board if it's on a heat pump or straight air conditioning system. If it's on a heat pump, you put it on the yes position, and that enables the O terminal for the reversing valve for cooling. If it's on a straight cooling unit, just a straight AC unit outside, team, remember that has to be in the no position. The heat pump jumper has to be in the no position, and then it ignores the O terminal. speed, high, medium, low on this particular control board. If you have a G only call on the board, in other words, the homeowner goes to the thermostat sub-base assembly and they switch the fan from auto to on, how fast does it run? Well, this is that jumper right there, fan speed, high, medium, low. Now, please make note of this. Low is about 35% of cooling airflow. Medium is about, and the reason I'm saying about is because on a couple of the products, it changes a little bit. Low is about 35% cooling airflow. Medium's 50%, about 50% cooling airflow. And high is 100% cooling airflow. So on this particular board, you're not actually selecting a speed tap like we did before, like on the TMY board. We're just giving it a selection of high, medium, low for continuous fan. If the homeowner just wants continuous fan, in other words, electrically, just a G call to the board, and that's the only call going to the board is G, fan only call. How fast will that fan run? According to that jumper, high, medium, low. Again, about 35, 50, and 100% airflow, cooling airflow, if you have a G only call. Any questions or comments so far on the jumpers? Okay, below the fan speed, you have your blower delay jumper, and that's used for your heating off delay. Remember, TAME, all of our Champion furnaces, they have a 30-second on delay in the heating mode. Once you get flame proving, 30 seconds later, the fan comes on and you distribute heat into conditioned space. However, the off delay timing is field selectable. And so how long does the fan run after the call for heat goes away? That's that jumper right there, that blower delay. And that's your heating off delay jumper. And again, 60 to 180 seconds. Typically, we ship them from the factory around 90 to 120 second jumper position, but you have the selection from 60 to 180 seconds off delay on the heating. The final jumper we're going to talk about is our staging jumper. Now, unlike our previous boards that we talked about, the staging on this particular board, on the variable speed board, does not have the auto function. It doesn't have that intelligence built in on the board. We just didn't have enough room electronically on the board to do that. But we still give you a 10, 15, or 20-minute selection if you have a single stage thermostat. Now, remember, team, we always recommend that you use a two-stage thermostat on a two-stage product. But if you're stuck with a single stage thermostat and you've got your W landed right over on the W/W1, in other words, you're just stuck with a single stage heating thermostat, you can still get some staging function, but it'll be 10, 15, or 20 minutes. So if I get a call for heat, if the thermostat's still calling after 10 minutes, it'll go into second stage to finish the call, and so on. So this is strictly a time function, 10, 15, or 20 minutes on this control board. And as before, team, if you're stuck with a single stage thermostat, put it someplace. Because if that jumper is in the off position, and I'm stuck with a single stage thermostat, and it's in the off position, you will never go beyond first stage heat. So please keep that in perspective. The final component on the board, you're going to notice that we have a model ID plug, and what this is just a little simple wire plug. It's just got some wires on it. There's no electronics on it. There's no resistors or any kind of a jump drive or anything like that. It's just simple little wires on that little harness there. And what it is, it configures the board. It's a model ID plug. It configures the board for the size of the furnace it's hooked to. And so it's an important thing that if you have a replacement board, be sure and take the model ID plug off the old board and snap it onto the new board. And then the first time you power that board up, it'll know it's on a particular size furnace. So from an inventory standpoint, this is really kind of cool because now you don't have to have 57 different boards on your truck for these furnaces. Basically, that model ID plug, it tells the board what furnace it's hooked up to. That concludes the roundabout layout of our two-stage variable speed board. As a matter of fact, that concludes our training today as far as our control boards. At this time, I'm going to go ahead and offer to let's open up the floor. We're about an hour and 20 minutes into our training, so we got plenty of time. If we have any good questions or comments, let's take a minute or two if there's any good questions or comments. And so unmute your mic, ask those questions as we kind of round out our training for this afternoon.
Joel, we've really focused on the on the control boards and detailing of that. Since we have some time left, would you want to make some comments on feature function benefits of the furnaces and other things that contractors like about the furnaces and how easy they are to install and that kind of comments?
Absolutely, I'd love to, Tony. Some of the things that you guys are going to really like about our Champion furnaces is they're all 33 inches tall. That's one of the things I really like about it, so you can count on them being the same height. The other thing that I really like about our Champion furnaces is the fact that they're all four-way convertible. And so even our high-end, 98% condensing style furnace, they're all four-way convertible. And so you can go upflow, downflow, horizontal, left and right. And so that's a real nice feature that contractors like a lot, Tony, because now they don't have to try to think of, unlike our competitors, let's see, I buy a downflow and lay it this way, and I buy a upflow and lay it that way, and what do? All of our furnaces are four-way convertible. In addition, even our high-end condensing furnaces, instead of having a bunch of traps and a whole bunch of parts that you have to try to configure, we have a built-in four-way collector box that allows the condensate to collect, and it's built in. And so all of our furnaces, all of our 95% plus furnaces, our condensing style furnaces, basically, you lay them the way you need to, you turn the vent motor where you need to vent it out where you need to, and then you have that real simple little drain line coming out. You have one little drain line coming out of the cabinet. You don't have a bunch of complicated traps and all that kind of stuff. So from an install standpoint, it's once you put a couple in and you see, oh gee, I see how I have to turn my induced draft blower and all that. It's just a piece of cake. They're one of the best furnaces I've ever seen in the industry. The other thing is lifetime heat exchanger, and that's a real lifetime heat exchanger with registration. And from a durability standpoint, in our torture chamber down there at the factory, we've got a furnace down there that we have over 1.5 million cycles on it. And TME, that's equivalent to about 110 years of operation, and they still haven't broke that heat exchanger. They've had some pressure switches that have gone bad and stuff like that, but they're trying to break that heat exchanger, and they still haven't cracked that heat exchanger after 1.5 million cycles on the thing. So very, very tough furnace. We just don't see issues with the heat exchanger. They're easy to put in, one little simple drain line coming out. And then, of course, very conventional wiring, and on our like a variable speed two-stage product there, you can go 24 volt or communicating. Just a good, solid, versatile, reliable product, Tony. Good. That's a good question. Any other good questions or comments before we start winding up for today? Well, team, I'll tell you what then, on behalf of your Champion team and our Winsupply hosts, we really, really thank you for the opportunity to train with you today. We are, as I said, we are recording this session, so we've been having a couple little bugs on how to get everybody the recording, but we are recording it. We're looking at setting up a dedicated Champion YouTube channel that you can just go in and look at the videos to your heart's content. But thank you so much for training with me today. We've got a couple more training sessions over the next 2 Thursdays. We'll send those invitations out today or tomorrow. And again, thank you for your attendance today, and please stay healthy. Thank you.
Thanks, Joel.